Where'd you find this?
This is the lesson video for section 7 or 1.4, which is about measuring, classifying angles, and also working with properties of congruent angles. What you need to know as we get started talking about angles are some definitions about the pieces and naming of angles. So a ray is similar to a line, but it has an endpoint, and it only keeps going in one direction. It looks like this: a endpoint here at point B, and then it goes through A and keeps going. So when you name a ray, you're going to name it similar to a line, but you should always start with the letter that is the endpoint, and then the arrow should go in the same direction as it does in the diagram. You should not name it AB because it doesn't start at point A and go through B. An angle, which is what this section is all about, is really just two rays with a common endpoint. So what that looks like, you've got an endpoint here and two rays going in different directions. You name an angle by using a couple of different methods. If there's only one angle at this common endpoint, you could call it angle C. Often you'll see a number inside the angle, and so you could call this angle 2. Otherwise, you need to use all 3 points and start along one ray to the common endpoint and then through the other side. So you could call this angle ACB. You could also start at point B and call it angle BCA. Congruent angles, just like segments, they're two angles with the same measure. You indicate that in a diagram with these little arcs right here. And then writing that angles are congruent, you still use the congruent symbol we learned about with segments. Finally, an angle bisector is a ray that cuts an angle in half. So what that looks like, if you have an angle and then another ray through the middle, that makes two congruent angles out of that larger one. That is called a bisector. The angle addition postulate is very similar to the segment addition postulate. And for this, you're still going to continue using the part plus part equals whole idea. If you have two angles that make up a larger angle, you can add them together to equal the bigger angle. To start with this section, we're practicing naming sides, angles, that kind of stuff. Example 1, part A says, name the vertex of angle 2. The vertex is just the common endpoint. It's just the part where the two rays come together. So the vertex of angle 2 is this point R. The sides of angle 1, here's angle 1 right here. The sides, all you're doing is naming the rays. So one side is RS, the other side is RP. The sides of angle 3 start at R and go through Q, as well as going through T, so you have RQ and RT. Angle 1 right here, there's two other ways you could name this. You could not call it angle R because there's multiple angles at that vertex, but you could call it angle SRP or angle PRS. So with angle 2, a couple of names for that are angle PRQ and angle QRP. The last one is kind of a trick question. How many total angles are shown in the picture? There's obviously the 3 smaller angles. There's also the one big angle that they all combine to make. But there's also the angle made by just angles 1 and 2, and the angle made by just angles 2 and 3. So really there's 6 total angles in that picture. Some additional vocabulary that you need to know: a zero angle is an angle with 0 degrees. When you have overlapping rays, there is no other angle that opens up, or other ray that opens up to make an angle. An acute angle is an angle that is between 0 and 90 degrees. A right angle is an angle with a 90-degree measure. It looks like that. It's also called a square angle, and it gets a little square symbol in the angle like that. An obtuse angle has a measure between 180 degrees, and it is, or not between 90 and 180 degrees. So really it's just bigger than a right angle. And a straight angle has a 180-degree measure. Essentially, that's just two rays that point in opposite directions, all the way from one side to the other is 180 degrees. So the first thing you're doing is measuring angles. To measure an angle, we need to use a protractor. How you use a protractor, you put the center point right on the vertex, and you need to line up the baseline along one of the two rays. So for this one, I've lined it up going this way. There's two sets of numbers on a protractor. You want to use the set that starts with 0. So since it opens to the right, I'm using the inner set of numbers. And then you count up. I see it's past 30, past 35. That looks like 37. Next example. If I line up this protractor right on the point, put the 0 line along one ray, this should actually be overlapping perfectly. But then again, I'm using the interior numbers for this one. And if I come all the way over here, it looks like it's past 125, but that's because it's up a little bit. So if this were put right on that vertex, that would be right at 125. Couple more examples. This angle is a 90-degree angle. You can see it goes right up through the 90. Then this angle, notice this is too small. You can't really get a good idea. You might be able to estimate, but if you really want to know exactly how big an angle is, you need to extend that line a little bit, and that really helps you to see that this is a 75-degree angle. Okay, so here's how we're going to be using the properties of angles. These problems will work a lot like segments using the angle addition property. You'll have some information given about the problem. So here I see angle 1 is 6x minus 2, angle 2 is 7x plus 12. It also tells us that angle ABC, the larger angle, is 140 degrees. So if I want to find angle 2, first I need to know x. So setting up the equation is just a part plus part equals whole problem. Then combine like terms and solve from there. So you end up with x equals 10. You're not done yet because this asked you to find angle 2. So you need to substitute your variable value back in for angle 2. So you're going to do 7 times 10 instead of x plus 12, which is 82. One more example here. It tells you that PN bisects angle MPR. So that means that angle MPN and angle NPR are congruent. So the first thing I would do is add those arcs in there. Then the next thing to do would be to add the given information. Angle MPN is 2x plus 14. NPR is x plus 29. You're not given anything about the whole size of the two angles combined, but since you know that they're congruent, because of that word bisects, you can set them equal to each other. So then solving for x here, you end up with 15, and then the final part of the question asks for angle MPR. So we need to substitute that 15 back in to each one. So 15 plus 29 is 44. If half of this angle is 44, that means that both angles are 44 and the overall size of MPR is 88 degrees. For example 5 and the your turn, I'd like for you to give those two a shot. Give those a try. We'll talk about them in class.